Hi, I'm Pagara12, and today we play with jump flood algorithm, and we build this network from scratch. And what is jump flood algorithm, or JFA? It's something that fills a texture with certain values, which are the values of a particular shape or contour. Recently, Simon did a wonderful tutorial, and he goes more into detail about this JFA algorithm. He's using a component done in glsl by David Brown. You can find it here. Also, Georgios Cheruvim done years ago a wonderful SDF talks. Also, Ia Chen has a component, same JFA component done in glsl. So those three, and for sure there might be a couple others, but those are fast, okay? And today we do a trick, because we don't need necessarily a fast JFA, while, for example, we are projection mapping a facade with some windows, because the windows doesn't move, okay? So anytime you need to do a projection, and your particles or your content should interact with some shapes, windows, and so on a building, those shapes doesn't move. So yeah, this trick it's good enough, okay? And in a later tutorial, we'll use a small part, maybe at the core of the component in glsl. But yeah, let's build this, and I will close this, okay, to guide me. I'll have this here to guide me. Okay, so first let's have a constant chop and resolution. Let's go with 1280. Pmap is 32, so obviously 32 by 32 will have 1024 particles. The radius, it's 1 divided by 256, okay? Now, yeah, let's have a shape. So movie file in, let's bring the starfish, okay? Now, we fit this in our resolution, okay? And this has to be 32 RGBA, and yeah, let's fit outside and maybe make it 0.8 like this. And yeah, let's see the contour. So first I'll have a threshold, okay? So let's see what I threshold. I threshold alpha, I believe. Okay, with 0.5 it's good. Now we're good. And the edge, okay, you see that the edge is always double, one line outside the shape, one line inside the shape. And I would like to have this a little bit thinner, so I'll go with multiply, like this. So now my edge is 1 pixel. And I want to initialize those pixels with UV values. So for this, let's have a UV. And this component is nothing but 2 ramps, horizontal, vertical, reorder, red, green, and yeah. And now we multiply like this. And here is the UV colors for that shape, okay? So remember I said JFA, it's a texture in which all the pixels are those colors, okay? Now, how is that possible? Let's have a null, insert a null inside collapse selected. So this is JFA trick, because we use cones like in Voronoi tutorials. Okay, so we don't need this out right now. This null 2, I have I'll rename it position, and yeah, it's crazy color because we will use it for instancing. Okay, and I want to instance a cone, so I'll make a cone out of a tube, and the first radius is 0. We need polygon, z-axis, we drag the height into center z, minus, it has to be minus divided by 2. So, and now a geometry, okay, and we use instancing, and we need to drag this. This is quite big, okay, so there will be way too many cones maybe. So what I suggest, let's reduce this to 256. Okay, now we go inside and drag this position, and we go with RG, and also for the colors we drag the same texture, R, G, and B, and you'll notice some drops, and those are because you see this big area of black. To solve this, because this area of black are actually all those transparent pixels for which I have a cone in a 0, 0 position, okay? But the moment I say active channel is red, now everything that is not red, it's alpha, okay? Okay. Anything that is 0 would be inactive, okay? Now we need a camera. A render. Okay, let's go here. Okay, so this render is the resolution 32 RGBA and anti-aliasing is off, and we need a constant. Okay, now the camera is orthographic, bottom left, and 1. And what we have here is JFA. So how come all those colors are only the one that we saw in an edge? Okay, you can check it very simple. If you look at the points, you'll see the points are the shape now. So, okay. Now we have this GFA, but the resolution is small, right? Now let's see what happened if we go back with 1080. I have a huge drop, like 6 FPS. But the moment I lock my null here, that means this component doesn't work. It's no needed to work as a, and you can double to be safe. Let's press this little X to not have this component cooking. He is not cooking anyway while we have this texture output, this output, it's locked. Once we have this, let's go with subtract, and you see why we were needed a texture in which every pixel is the edge, okay? Because now in this UV in which every pixel it's in a grid. If we subtract those two, okay, we get the texture that we need. This texture, let's okay, this texture you can actually normalize this just in order to see it better. Okay, like this. So this is the texture with the I would say perpendicular directions on the edge lines. Okay, and yeah, how we do particles going around the starfish. Okay, so let's have a initial particles. So with a noise initial position for the particles, the texture is 32 by 32. We are RG, not monochrome, and let's go with random GPU. Okay, right after we use a feedback. Okay, I always color the feedback black. I don't know why. So keyboard in, with this K1 we can pulse and or feedback or reset the feedback. Okay, what goes here, it's add with the direction. Let's add with 0 right now. Okay, so I need a constant, and I connect a constant to the feedback only for the resolution. So my constant now, it's 0. If I add something with 0, it stays the same. So now this addition goes back into the feedback, and this is the particle system. Okay, which now the particles are so dummy they don't move because the direction it's 0. Okay, now what if let's have here a null, and I would like to see those points and the starfish. Okay, so let's build a render. So we need a circle. Okay, we take this radius, 32, it's enough. Okay, now geometry. Okay, and yeah, this is position again. I color this crazy color like this pink, and I drag this for the instancing. Okay, RG. There's no need for to active now for the active, and now a camera render. Camera is orthographic, bottom left 1. This is 1080 by 1080, 32 RGB. Okay, we don't want NTLS. So this is null, and yeah, this might be final. Okay, now I would like to see this. Split left and right, take the top. Okay, now yeah, we need a constant for the color, so not now here. Okay, we are good. And I would like to see the star here, so let's have a select, and let's get the star like this, and I use over. Okay, for this starfish. Let me use here a level. So I want to increase the brightness a little bit. Okay, this is much better. And now we have those particles that are not moving, okay? The moment you change this with a noise, let's have a noise here. Okay, at G, and yeah, they start moving, but it's way too fast, way too fast. So what we can do is have a math here, and we divide by how many pixels we have. So we make sure the vector direction here, even if it's huge, okay, like maybe 1 or 2, but it is divided by how many pixels. So if this vector is length 1, the speed will be okay to travel each pixel. Okay, now, yeah, you see, but obviously the direction are random. This is noise, so we want to make use of that texture with those directions. Okay, so let's have a null here, and let's bring it with a select here. Okay, and now I have my points here, and I want to check what's the direction in this texture where my particles are. So for this we use remap, like this, UV image, and yeah, let's connect this one here. So let's like this. So we don't need the constant and the noise anymore. Okay, now they go, if you see, all of them are going in a direction that is actually perpendicular on edge. Okay, and I would like to have them going round and round, and what we need to do is just make a perpendicular vector to this one here. So instead of this, we build a perpendicular. So okay, now how this is done, we need a reorder. Okay, for which we change the green with the red, and then we need a math, and we have to decide we multiply only for the red or only for the green. So let's mask the green, and we multiply the red with -1. Okay, and yeah, let's mask alpha also. Okay, now they are moving now. Let's check to see if they are moving good. So I would like to have here a feedback. Okay, yeah, are going very nice. Okay, so I would like to drag the 1 key here to reset also, and 0.99 to have a little bit of longer tails. Okay, and yeah, this is the motion that I wanted to achieve. And let's have some colors, and for the colors I would like to select the same fit. Okay, and yeah, let's use a noise. And I want this noise to be maybe I'll go like this. So this noise is the same resolution, RGBA, not monochrome. I can over this now. Okay, and yeah, I'll have some colors. We are good. Like this. Now I want to see in the for those pixel position what color should have. Okay, and we actually do the same remap. Okay, so I remap this. It should be not it should be RGBA. Okay, and yeah, let's have this null. We name it colors or color, and yeah, it's crazy pink because we use this here for the colors, R, G, and B. So yeah, this is good. We can go crazy with this texture. Okay, so 64, and let's have here a smaller radius. Okay, and yeah, let's see if without over, maybe I'll have some points that are not moving, you know. So and they change color. Oh, sorry about it. So obviously if those points are moving, okay, their places is different each frame, and so the color is different. Okay, now I want to keep the color, and for that you don't remap with the feedback, you remap with the initial. So now it's good, right? And obviously the inside of a starfish is a different color because this is how we build the texture. But I want to show you some points that are not moving at all. Okay, and most of the times this is on edge, because if you check here this texture, the edge itself, the value here where we have a black pixel, it's 0. So it doesn't know where to go. We can use a blur. Okay, so if we use a blur here, okay, some, you already saw them, some will start to move. Okay, what I don't really like about is the moment you blur being the average, it will be an average of between 0 and something very close, which is 1 in length, my normalized vector. Okay, so yeah, I don't like that, because that means you need to, oh, sorry about that, that means you need to normalize again in order to have a correct one length directions. So instead I go with blur here right after the subtract, and yeah, now you have all the dots moving, so it's good. And yeah, you can play with colors and or shapes or speed, anything. If for the speed, for example, here you can multiply, right? So let's multiply with speed. Okay, so that's okay. We don't have yet speed, but okay. Let's go in a constant, and we say speed, it's 3 or 2, and now 8. They are going faster. Obviously, some dots remain, because the jump is bigger than 1 pixel. So here the solution would be to have a line in between two neighbors pixels. And yeah, I have a couple of tutorials with that also. So yeah, this was my tutorial. I really hope you like this. Thank you so much for watching, and you can support me on Patreon. You'll get access to a bunch of other tutorials, a bunch of little tools that we gonna use in future tutorials. And yeah, thank you so much for supporting me. I want to thank to all my Patreon, and I'll see you in the next one, which will be in a couple of minutes, and we do collisions, particles with whatever shape using SDF. So see you there. Bye.